Hi everyone, welcome to Technology World Up. My name is Anil. In this series, I am going to start one new important topic, that is core Java. In any automation, if you want to become a key automation guy, key automation tester, then you must know one programming language. So nowadays, core Java still in demand. So if you want to make your career on automation, you must be knowing thoroughly core Java. Let's start this. So in this module, I'm going to cover introduction to Java and OOPS concepts. That's how I have written first module as core Java for test automation. So how core Java helps in test automation, and it is mandatory. If you want to make your career in automation, you must know core Java. So let's say introduction to Java. Basically, Java is high-level, object-oriented, platform-independent programming language developed by Sun Microsystem, now that is owned by Oracle, which was in 1995. It follows the principle write once, run anywhere, meaning Java code can run on any machine that has the Java virtual machine, JVM. Okay, so basically Java is a high level object oriented platform independent programming language and which is developed by Sun Microsystem in 1995. It follows the principle write once, run anywhere. That means you can write down your code in any programming language. For example, you write down your code on Windows, but that same code you can run on Mac or Unix or Linux, but you should have a virtual JVM. That is, particular JVM should be installed on that operating system. Okay, so Java is widely used for web applications, mobile apps, especially Android, enterprise systems, automation and testing, cloud and distributed applications. Okay, Java is mainly used for these things. Okay, then what are the key features of Java? Java is simple, that is easy to learn and write. Object oriented. Everything in Java revolves around objects and classes. Platform independent. Bytecode runs on JVM, not hardware dependent. Okay, so platform independent. That means, as I mentioned some time back, let's say you have written one program in Windows. So what you will do, we will just compile that and it will create the bytecode. And that bytecode you can run anywhere. It's called bytecode will be run by JVM. Okay, bytecode runs on JVM. So that means that bytecode you can run anywhere, any operating system, not hardware dependent. That is, next one is secure. Provides runtime security, no explicit pointer manipulation. There is no concept of pointers. Robust, strong memory management, exception handling, garbage collection. Then next one is multi-threaded. Supports concurrent execution of tasks. Multiple tasks can be executed simultaneously. Then high performance, JIT, that is just-in-time compiler, improves execution speed. Okay, there is a JIT, just-in-time compiler, which improves the execution speed. So compiler basically runs code line by line, but JIT compiler will run multiple lines of code at a time. So that improves the execution speed. Okay. Then next, the most important thing is object-oriented programming concepts in Java. Java is purely object-oriented except for primitive data types. Except primitive data types, Java is purely object-oriented programming language. OOFs, that is object-oriented programming, that is called OOF. OOF organizes code into objects, that is real-world entities that contain data, that is fields, and behavior, that is methods. Okay, data is called fields and behavior is called methods. Okay, OOFs organizes code into objects. Basically, whatever code we have written, so OOFs, what it does, it organizes code into object, that is real world entities that contains data, that means one program contains what data, that is field, and behavior, that is method. So basically one program contains methods and fields. So that fields are nothing but data and methods are nothing but behavior. Okay. Then what is a class? Everything, because everything we develop or write inside a class. Let's first understand what is class. A class is a blueprint or template for creating objects. Basically, how we will create objects? We will create objects inside a class. That's why a class is a blueprint or template for creating objects. So without class, we cannot able to create objects. It defines attributes, that is variables, and behaviors, that is methods. So basically class defines attributes, that is variables and methods, which is required for a program or execution of the program. Think of a class as a design of a car. Let's say there is a car. Let's consider car as a class. Okay. Then what is an object? An object is an instance of a class. So object is an instance of a class. It represents a real world entity. So basically object represents a real world entity. Each object has its own copy of variable, that is state, and can call methods, that is behavior. For example, think of an object as an actual car built from the design. Okay, it's an actual car. Okay. Let's take one example, class and objects in Java. So we can take one example. Let's say consider class car. Okay, class definition. Let's say car is a class. Okay. So it has attributes, that means attributes is variables. So one class, car means car have brand, car have color, car have speed. Okay, so that's why let's take different attributes. So car attributes are, let's say string, brand, there will be brand, different type of brand, Maruti, BMW, Ertiga, Mercedes, so many brands are there, right? So string, brand. String color, again there will be different color, white, blue, red, yellow, different colors, right? So string, color. Int speed, so different car having different speed, right? So that is int speed. Speed is in kilometer number, so that's why it is integer. Okay. And then again car will have some behavior, that is drive. So what happens, like we need to drive the car, then apply brake. Okay, these are behaviors. So drive, word drive, system, that is called methods. Behavior is nothing but methods. Okay, so there are variables and methods. So variables are nothing but attributes, that is, let's say brand, color, speed. Behavior is, let's say drive, apply brake. So what we do, we drive the car, we apply brake, we put the brake on the car, okay, while driving. So these are the behaviors. So void drive, system.out.println brand plus is driving at speed plus kilometer. So basically we'll check brand, speed, okay, those things. So let's say apply brake, system.out.println, some meaningful name, brand has stopped, speed is equal to 0. Okay, when the car will stop, that time speed will be 0. Okay, then let's say take one main class. So main class, public class main, public static void main string args. Let's create one object. Object means instance of car. How will create object? So basically we require a class. Inside the class we create the object. So let's say we'll create object of car. So car1 is equal to new car. That's how we create the object. Car1 is equal to new car. So then through car we'll get the attributes. Let's say car1 dot brand is equal to Toyota. Okay, so let's say the brand will get it as Toyota. Car1 dot color is equal to, let's say, red. Then car1 dot speed is equal to 80. Okay, then similarly we'll take car2 is equal to new car. Car2 dot brand will take BMW. Car2 dot color is equal to black. Car2 dot speed is equal to 120. Okay, then we'll call the methods. So how exactly we'll call? Car1 dot drive. Car1 dot drive means basically it will go to drive. So whenever it will go to drive, so for car1 it will come here. Then what it will print? System dot print a brand. What is the brand? Car1 dot brand Toyota. So it will print Toyota is driving at speed. Speed means how much speed Toyota? Toyota is 80. So it will be Toyota is driving at 80 km per hour. Like that it will print. Then similarly whenever we call car2 dot drive, then what it will print? Car2 means BMW brand. BMW is driving at speed how much? 120 km per hour. Okay. Then car1 dot apply brake. Car1 dot apply brake means which brand? So Toyota has stopped. Speed is equal to 0. Okay, Toyota has stopped. Like that it will display. Okay, let's do one thing. Let's run this program. Okay, so that we'll understand it in a better manner. Okay, let's do one thing. Let's create one class. Let's open IntelliJ. Okay, in IntelliJ let's take one. Okay, so let's create one class. This is my package. Okay, inside this package let's create one class. What is the main class? Let's say the class name is anything you can tell. I mean let's say what I can tell, class object test. Let's say class object obj test. Okay, any meaningful name you can provide, not an issue. Okay, then what I can do, let's create one main method. Okay, so let's do one thing. Let's create one main method. So public, okay, public static void. That's how the Java program usually executes. So there will be a class. Inside that class there will be main method, public static void main, and inside the string args. This is the syntax for creating a class. Okay, this is the main method. So let's do one thing. Let's create one class. Let's say car class. Let's say car class. Let's say car. Okay, car is a class. Okay, so car class having some attributes. Let's say this is the definition. Okay, we can write down some meaningful name. Let's say this is the class definition. Class definition. Okay, class car. Let's say create one attributes. Okay, let's say this one is variables. Okay, so that means class have variables. So car class have different variables, like for example string brand. Okay, then similarly let's say string color. Similarly int speed. Okay, these are the variables. And also class car have some methods, having some variables and methods. So methods mean behavior. Methods. So what are the methods? Methods are nothing but behavior. Okay, these are behaviors. So what are the methods? Methods are, let's say, void drive. Void. So we drive the car. So this is the method. Let's write down some meaningful name. Okay, system dot out dot println. So what we can write down, let's say brand. Okay, plus we'll give some, okay, space. Let's say each driving at okay, provide space, then plus speed, plus speed, plus, then again put some space, let's say kilometer per hour. Okay, then next let's take one more method, that is void apply brake. Apply brake. Okay, so here let's write down system dot out dot println. So here what we can write down, brand, okay, brand has stopped. Brand is stopped. That means car got stopped means speed is equal to 0. If one car is stopped, then there is no speed, right? So in that case, we can write down speed is equal to 0. Okay. Then let's go to the class object test class. Okay. Here, what we are going to do, we will create objects. So creating objects. That is instances of car. Okay, instances of car. So how will create the object? So basically we'll write down car, let's say car 1 is equal to new car. That's how we'll create the object. Okay, car 1 is equal to new car. Then after that, through objects, we will call the attributes. Let's say car 1 dot brand is equal to, let's say we'll take it in the Toyota. Okay. Then let's say car 1 dot color. Okay, car 1 dot color. Let's say car 1 dot color is equal to, let's say, red. Okay. Then let's say car 1 dot speed is equal to 80 km per hour. Let's say 80. Okay. Similarly, so let's do one thing. No, let's create one more object. Let's say car. Okay. Let's say car 2 is equal to new car. Then car 2 dot, let's say, brand is equal to, let's say, BMW. Okay. then car2 dot color, let's say black, anything you can mention. Then car2 dot speed is equal to, let's say, 120. Okay, then after that what you can do, you can calling methods using objects. So what we'll do, we'll call methods using objects. Calling methods using objects. Okay, so how we'll call the methods? Through the object only we'll call the methods. So let's call the method, let's say car1 dot, let's say which one, drive. So whenever I will call car1 dot drive, then control will go to drive method. So here what it is written, system dot print brand means car1 dot brand, which one, Toyota. So it will print Toyota space is driving at 80 km per hour, speed is equal to 80. Okay, so let's run this and we'll see the result. Let's run this. Let's see the result. Okay, let's hold on. It will execute and show the result. Yeah, it's a little bit slow. Hold on. It is going to execute. Okay, and it will show the result. Just hold on for some time. It will execute and show the result. See, absolutely working fine. So result is Toyota is driving at 80 km per hour. Similarly, if we will call, let's say car2 dot drive. So what it will print? It will print, sorry, 1 minute. Similarly, what it will print? It will print car2 means which one? BMW. BMW is driving at 120 km per hour. Okay, let's execute this. Let's see, absolutely working fine. See, Toyota is driving at 80 km per hour, then BMW is driving at 120 km per hour. Let's say I will call car1, okay, car1 dot apply brake. Okay, so which one it will call? It will call Toyota. So what it will print? It will print Toyota has stopped. Okay, let's execute this. We'll see the final result. See, absolutely working fine. First one is Toyota is driving at 80 km per hour, BMW is driving at 120 km per hour, then Toyota has stopped. Okay, absolutely working fine. Got it? So that's how it is. Yeah. Let's move. Same program we've already executed. Yeah. What are the key points? Key points is class. What is class? We understand class is the blueprint, that is car design. For example, in this class. Then what is object? Object is instance. Instance of a class. Class is blueprint for object, and object is instance of a class. That is car1, car2. Objects can have different values but share the same structure or behaviors. So basically objects can have different values but they share the same structure and behaviors. Okay, that means different cars have kind of similar structure, car structure, and almost similar behavior, right? Car cannot be look like as a truck or something like that. Okay, so that's why objects can have different values. Value like speed may be different, name may be different. Brand name may be different, engine may be different, but their structure and behaviors are same. That's how it is. So that's why objects can have different values but share the same structural behaviors. But the core OOPS principles. So there are four core OOPS principles are there in Java. That is encapsulation, inheritance, polymorphism, and abstraction. Okay, let's discuss one by one. Encapsulation. Binding data. Data means variables and methods, that is functions, into a single unit. That is called encapsulation. Binding data, that is variable, and methods, that is functions, into a single unit. That is called class. It's called encapsulation. So binding the data and methods inside into a single unit in a class is called encapsulation. Provides data hiding using access modifiers, that is private, public, etc. Example, private int age, public void set age int a is equal to age is equal to a. So how we do? We use private variables and those private variables we access through public methods. Okay, using getters and setters. What is an inheritance? Inheritance is a mechanism to acquire properties and behaviors of another class. So this is the mechanism by which one class will get the properties from another class. That is, child class will get the properties from parent class. That is called inheritance. It promotes code reusability. So basically, same code we can reuse. Let's say there is a code which is present in parent class, same code we will use in child class. Uses as extends keyword. So how basically it will get the property, it will extend. Let's say class A extends class B. That means B is the parent class and A is the child class. With extends, it will get all the properties of the parent class. For example, class dog extends animal. So dog is the child class, animal is the parent class. Okay. The next one is polymorphism. Ability of a method or object to take many forms. So poly means what? Many. Morphism means forms. So many forms. The ability of a method or object to take many forms. Types, compile time, that is method overloading, and runtime, method overriding. And polymorphism is two types. One is overloading, and method overriding. So method overloading happens during compile time. Same method name, different parameters. So same method name with different parameters. That happens during compile time. Runtime runtime means method overriding. That is, subclass provides specific implementation. Let's say there is a method which is present in parent class, same method present in subclass, but their subclass will provide specific implementation. Okay. Then next one is abstraction. So here abstraction is nothing but hiding implementation details and showing only essential features. Achieved using abstract classes and interfaces. So abstraction we can just will show the essential features and will hide implementation details, and it will achieved using abstract classes and interfaces. Example, abstract class shape, then there is a method class abstract void draw. This is the abstract method inside the abstract class. Okay, let's do some example, then we will clear on that. Simple Java example with OOPS concepts. So how? Let's understand the example. These examples contain encapsulation, inheritance, polymorphism, and abstraction. All four OOPS concepts it contains. Let's consider abstraction. Let's say there is a abstract class animal. So this abstract class animal has, let's say, one abstract method that is called abstract void sound. Okay. Then what it will happen? Basically, dog class demonstrate inheritance, polymorphism, and calculation. Okay. So let's say dog class extends animal. That is inheritance. So class dog extends animal, and this dog class have some private variable. Let's say private string name. This is again comes under encapsulation. So there is a constructor that is public constructor. Public dog string name. This dot name is equal to name. That we have. This dot name means we are just calling the current class object. Okay. This dot name is equal to name. We are providing the name. Then we are putting getters method. Okay. Public string get name return name. Okay. Then we are providing again setters, because encapsulation we just through getters and setters will access the private variables, right? Setter public void set name string name this dot name is equal to name. Then at the rate override void sound. So basically we are overriding sound class from where? Animal animal abstract class, and we will implement that. So we just override that, override void sound, then system.out.println meow. Okay, cat. There is a class. Okay, there is a cat class actually. So, okay, dog class completed here. Then there is a cat class. So class cat extends animal. Again, it is inheritance, and cat class will basically override animal class sound method. Okay, so void sound system.out.println mew. Then let's come to main class. Let's say public class main, public static void main string args, and it will let's instantiate animal class with dog, because we know animal is a abstract class, so abstract class cannot able to instantiate. So it basically required is implemented class will instantiate it. Okay, so dog class is the implemented class for animal abstract class. So dog class will basically, what it will do, it will help in instantiation. Okay, so animal a1 is equal to new dog. That means with the dog class will instantiate animal class. Okay, so after that what we'll do, we'll create, let's say animal a2 is equal to new cat. Cat also implemented class of abstract, I mean animal abstract class. So cat can also instantiate. So animal a2 is equal to new cat. Let's try to understand it. Okay, here again polymorphism concept, because dog. Okay, so what we are doing, we are passing body. Okay, with the new dog we are passing body. So whenever we call new dog and we will provide body, then what it does, it will call the dog class constructor. Correct? You will see here in dog class there is a parameterized constructor. See, public class dog. So that means we are providing body. Body is the name. So string name, that means body. So this dot name is equal name. That is, what is the name? Name is body. Okay. Variable name is body. Then what we are doing, we will call a1 dot sound. Okay, whenever we call a1 dot sound means it will call which sound method? Dog class sound method. So here So when we call a1 dot sound, so it will basically call dog class constructor. Then it will print system dot out of println name. Name is which one? Body. Body says oof. So it will print body says oof. Understood? Yeah. Next one is whenever we will call, let's say a2 dot sound. A2 means which one? A2. A2 is how we are creating A2 with the help of cat object. Okay. So that means A2 will call cat class sound method. Okay. So cat class sound method means it will print mew. Okay. Then how will get the encapsulation? So then what will do? Dog is equal to dog of a1. Okay, dog of a1, because a1 means what? A1 is a reference of animal class. So animal class. So basically we are converting. Okay, so we are converting animal class into converting dog into animal. Okay, animal, just we are converting animal class into dog, and we are storing here, let's say. So dog is equal to dog of a1. So now we'll print system dot out dot println dog's name colon plus dog dot get name, that is dog. This dog is which one? Animal class reference. Okay, so that means dog dot name means it will be, what is the name of dog? Body. So it will print body. Dog's name body. Okay. Then dog dot set name Charlie. Then again what we are doing? We are setting the name as Charlie. So when we call dog dot set name, so basically it will call which method? It will call, yeah, it will call this method. Public void set name. So string name. So name what we are passing? We are passing Charlie. So again it will be this dot name is equal to name. So name will be, now name will be Charlie. Okay. So now what we will do after that, if we will call, let's say we will call dog dot sound. So when we call dog dot sound, so it will basically come here and it will print Charlie says oof. Okay, it will print Charlie says oof. Understood? Okay, perfect. Let's do one thing. Let's create this program and execute it so that you can understand it in better manner. Okay, let's do one thing. Let's create a class. Okay, suppose let's create a one more class. Let's say the class name is, we'll give something, oof test, something like that. Oops test, something, any meaningful name you can provide. I have given just oops test. Okay, then after that just let's write down main method, public static void main. Okay, this is the main class. Okay, public static void main, then string args. Okay, then what you can do, let's do one thing. let's uh, yeah, let's do one thing. Let's implement all the oops concepts, that is encapsulation, encapsulation plus which one? Inheritance plus polymorphism plus abstraction. Okay. Then let's do one thing. Let's create one abstract class. Let's say abstract class animal, suppose. Okay, there's the abstract class which is called animal. So we require abstract, I mean abstract keyword we require. So this is called abstraction concept. Okay, abstract class animal. Let's say there is a abstract method, abstract, let's say void, let's say sound, without implementation. Okay, abstract method means no implementation. Okay, then let's say there is a class called, let's say, dog class. Okay, let's say class dog extends animal. Okay, let's say class dog extends animal. 1 minute. Okay, then if class dog extends animal means, so it need to what it need to do, it need to implement. Okay, do one thing. Let's say this is called what? This is called inheritance, this concept, right? This is called inheritance, correct? So we can write down here, let's say dog class demonstrate dog class demonstrate demonstrate demonstrate. Okay, dog class demonstrates inheritance. Okay, loss polymorphism, polymorphism, loss encapsulation, encapsulation. Okay, so let's say class dog extends animal, right? Then encapsulation means private field. Encapsulation means what? Private field. Private field. Okay, let's say private string, let's say name. Okay, then let's create one constructor. Okay, constructor, that is, let's say public dog. Okay, there is a parameterized constructor, let's say string name, and how will pass the value? This dot name is equal to name, current class reference. This dot name is equal to name. Okay, then 1 minute. Yeah, after that it have the, so what we'll do with getters and setters? So what we'll do, getter control access to private data, so it will control control access to private data. Okay, then what we'll do, we can write down one public method, public string get name, public string, okay, public string get name. Okay, public string get name. So here we'll return name, return name. So it will return name. Similarly, we'll write down setter. Okay. So what setter does? Setter will control modification of private data. So it will control modification of private data. Okay, it will control modification of private data. Setter. Okay. So let's write down public. Let's say public void set name, then string name, okay. Let's say this dot name is equal to this okay, public void set name, let's say string name, then this dot name is equal to name. So after that, okay, this dot name is equal to name, then after that what we'll do, we'll let's say override at the rate override. What will override? We'll override the void sound method. Okay, sound method of which class? Animal class. Okay, so here, 1 minute, this is the sound method, right? Void sound. So what is the concept here? This is polymorphism, that is overriding. Polymorphism that is overriding. Okay, polymorphism overriding. Understood? Void sound. Then what will write down? System dot out dot println. Let's say dog sound mew, meow, mew. Okay, then we will close this. Understood? One minute. So annotations are not allowed here. Okay, suppose yeah. One minute, just checking. Okay, let's say system.out.println. Let's say what I can do, I can write down, let's say name. Okay, suppose name says, okay, name says, let's say poof dog. Okay, something like that. Then after that, what we can do, let's say there is a cat class. Okay, just I'm trying to, okay, 1 minute. Set name. Mm, okay, so I believe, 1 second, let me just see this. Yeah, perfect. Yeah, this is not required. This is not required. This is extra actually. Let me. Perfect. So now it is working fine. So there is, let's say, there is one more class. Okay, let's say class cat, and that cat extends which one? Animal. Cat extends animal. Okay, class will also class cat extends animal. So that means which concept? Inheritance. Okay, inheritance. That means it will implement the method. Correct. Void sound. Okay. Then system dot out dot println. Let's say mu. Okay. Then public class. Let's say states. Public static void main string address. Let's instantiate the animal interface. Let's say animal a1 is equal to new dog. Okay, and the dog class actually contains one parameterized constructor. Remember, right? So then we'll just provide the name. Let's say body. Okay, this is called which one? Polymorphism. Because we have default constructor, we have parameterized constructor like that. So this is called polymorphism concept. Similarly, let's create animal a2 is equal to new cat. Okay, then so what we'll do, we'll call, let's say a1 dot sound. So whenever we'll call a1 dot sound, it will call which method? So it will call basically which one? A1 dot sound means dog class sound method. So here it will call system dot out of play. Name means body says oof. Okay, because we are passing the name as body, correct? So when we call animal a1 new dog, so it will call constructor of dog class. So that means basically it will call here. So name will be set as body. Body, this dot name is all name. So name will be body. After that, what it does, it will call the sound of sound. Okay, that means body says oof. Okay. Similarly, whenever we call, let's say a2 dot sound. Okay, so we'll call a2 dot sound. a2 dot sound. So in that case, what will, which one it will call? It will call sound method of cat class. So it will say mu. Okay. Then after that, okay, let's execute these two. We'll see the result. Okay. So basically first it will call body says oof, then after that it will display mu. Let's see this. Yeah, body says oof, mu, absolutely working fine, correct. Then let's do one thing, we'll do the typecasting. So basically what we'll do, we'll dog dog is equal to dog of, it is implicit typecasting, sorry, explicit typecasting, okay, because animal is the broader version and dog is the, animal is parent, dog is child. So we'll make dog is equal to dog of, let's say, a1, okay. After that what we'll do, we'll call which one, let's say system, just to print system dot out dot println, okay, let's say dog name, okay, 1 minute, 1 minute, let's say dog, sorry, dog name, okay, dog name plus which one, let's say dog dot get name. So dog dot get name, okay. So here what it will print, dog dot get name means which one it will print. So dog dot get name means basically it will print, no, it will basically go to go to a1. A1 means it will go to which method, dog class method, get name method, dog class get name method means here. So it will return which one, name means it will return body, okay. So that means it will print dog name body, okay. Let's let's run this, okay. We'll observe that it will print dog name body, okay. See, dog name body, perfect. Then after that let's set the value. So what we will do, dog dot set name. So in the set name, let's say we'll provide Charlie, Charlie. So we are setting the name as Charlie. So this is called setter method, okay. Setter, so we are using setter, okay, using, to write down using setter, okay. So now dog name has been set to Charlie, correct. Then next let's print this, we'll print dog dot sound, suppose, okay. So whenever we'll call dog dot sound, so it will go to which method, sound method of dog class. So then what it will print, system dot out dot print name means here we set the name as Charlie. So Charlie says oof, it will print Charlie says oof. Let's run this and we will see the complete result, okay. Let's run this. Let's observe, yeah, absolutely working fine, see. So initially it print which one, body says oof, mu, dog name body, Charlie says oof, okay, because we set the name as Charlie, okay. Got it. So that's how we have implemented. If someone will ask Question: where exactly we have implemented all your OOPS concepts? So you can provide this example. Okay, abstraction, inheritance. Okay, then polymorphism. Then which one? Encapsulation using getters and setters. Okay, so this is how we have implemented encapsulation. This one encapsulation. So this is the way you can explain. Okay, or you can write down a program using all the implemented OOPS concepts. Okay, then 1 minute. Okay, now this single program demonstrates all four OOPS pillars, that is abstraction. Abstraction is nothing but abstract class animal with abstract sound method. Okay, abstract class animal with abstract sound method. Inheritance dog and cat extends animal. Okay, then polymorphism a1.sound and a2.sound behave differently at runtime. Correct, because a1.sound and a2.sound have different behavior for both for dog and cat. Encapsulation dog class has private field name with getter and setter. Okay, dog class having private field as a name with getter and setter. Okay, that is called encapsulation. Understood? In short, what we can tell? We can tell that Java is equal to simple, robust, and platform independent programming language. OOPS concept is encapsulation, inheritance, polymorphism, abstraction. Make Java modular, reusable, and maintainable. Okay, that's it for today. I will come up with new topic. Till then, take care. Bye bye. Please like it, share with your friends and family, subscribe the channel. Take care. Bye bye. Thank you so much, guys.